Welcome back to Maths class of class 6. Students, we are doing the fourth lesson, Basic Geometrical Ideas. In the previous sessions, we have completed with some of the basic elements of geometry and we learned how to geometrically represent them by using symbols. In the previous session, we also learned about polygons. Remember, polygons are closed curves which are made of only line segments. And we learned about the polygon having 3 line segments, that is a triangle. Today we continue the topic by learning about another polygon which is made of 4 line segment. The polygon which is made of 4 line segment is called a quadrilateral. So let us understand more about the quadrilateral, the different parts of a quadrilateral. So what did I say? A polygon which is made of 4 line segments is called a quadrilateral. So here you can see I have made a polygon which is made of 4 line segments. This is a quadrilateral. Now let us understand the different parts of a quadrilateral. Now you can see the 4 corners. The 4 corners of this figure, this closed curve or a quadrilateral. These 4 corners are called the vertices of the quadrilateral. So how many vertices are there in the quadrilateral? There are 4 vertices. Let us name them. Because they are points, we will use capital letters to name them. They are A, B, C and D. Clear? The vertices of a quadrilateral. Now, you can see that, it is, as I said, it is made of 4 line segments. So, these are nothing but the sides of the given quadrilateral. So, let us name the sides AB, BC, CD and DA. And because they are line segments, we will use a symbol for denoting the line segment AB, BC, CD and DA. These are the 4 sides of the given quadrilateral ABCD. Now, you can see at the corners the angles are formed. We learned about angles in the previous class. So, you can see at the corners where 2 sides meet, angles are formed. So, how many angles are formed here? This is 1, another angle at this corner, 3rd angle and 4th angle. So how many angles in a quadrilateral? There are 4 angles in a quadrilateral. And remember, we learned about the naming of the angle. We can either name them by using the vertex or we can use 3 alphabets by putting vertex at the center. So because here they are specific angles, so we can name them as angle A, angle B, angle C and angle D. So, the 4 angles we have named. Now, let us go further by learning about the diagonals of the quadrilateral. So, what are the diagonals of a quadrilateral? For that, we had learned about the adjacent vertices and non-adjacent vertices. Adjacent vertices are the vertices which are the endpoints of the same sides. And non-adjacent vertices are the vertices of different sides. So, here, if you take non-adjacent vertices and join them, the line segment that you get by joining the non-adjacent vertices or the opposite vertices, it is called a diagonal. So, here A and C are the opposite vertices. So, if I join them, I get one of the diagonal, that is AC, and another 2 pairs are D and B, opposite vertices, and if I join them, I get the second diagonal, that is BD. So, the 2 diagonals of the quadrilateral ABCD are AC and BD. Clear? Now, we learn about adjacent side. Now, what are adjacent side? Any 2 sides which have a common vertex. Any 2 sides which have a common vertex are called adjacent side. You can name any adjacent side, for example, DA and AB. One of pair of adjacent side in which A is common, or if you take AB and BC, you have B common, that is another pair of adjacent side. BC and CD with point C common, another pair of adjacent side. So you can name many pair of adjacent side. So adjacent sides are the sides which have one vertex in common. Let us name any 2 pairs like AD and AB. AD and AB. Okay. Now you have adjacent angles. Now what do you mean by adjacent angles? The angles which are formed on the on the same side, that is, you have, if you take the side AB, the angles which are formed at each of its corners will be called the adjacent side. For example, if you take the side AD, the adjacent angles will be angle D and angle A. If you take the side AB, the adjacent angle will be angle A and angle B. Or if you take the side BC, the adjacent angle will be B and C. And if you take the side CD, the adjacent angle will be C and D. So you can name any pair of adjacent side, that is, it will be either A and B, angle A and B, or angle B and C. Angle B and angle C are one of the pairs of adjacent angle will be. Now next is opposite side. Now we learned about adjacent side. Opposite side will be the sides which do not have any vertex in common. For example, AB and DC. These are the opposite sides. Another pair of opposite sides will be BC and AD. So the two pairs of opposite sides in the quadrilateral ABCD are AB and CD, and one more pair you will get AB and CD, and another pair you will get BC and AD. Next we learn about opposite angles. You learned about adjacent angles being the angles formed on the corners of the same side. So opposite angles will be like angle A opposite to which is angle C. So angle A and angle C. And another pair can be angle B and angle D. So this is about the different parts of a quadrilateral you have to be clear with when you solve the problems relating with quadrilateral. So let us revise what all we have learned till now. A polygon having 4 sides is called a quadrilateral, and you can see on the screen the quadrilateral being made. The 4 edges or corners are called the vertices, and in the second figure you can clearly see the line segments forming the quadrilateral termed as the sides of the quadrilateral, and the angles being marked. How many angles are marked there? There are 4 angles. And in the third figure, the quadrilateral ABCD, the 4 sides, 4 angles and 2 diagonals are named. Let us see the second figure. The name of the quadrilateral is ABCD, and let us name the sides. The sides are AB, BC, CD and DA. And because they are line segments, we have used the symbol for the line segments to denote the sides. The 4 angles are angle A, angle B, angle C and angle D. Opposite sides are AB and DC, and another pair is BC and AD. Opposite angles are, one of the pair is angle A and angle C, and another pair is angle B and angle D. Adjacent side, you can see many adjacent sides being given there. AB and BC, BC and CD, CD and DA, DA and AB. And the adjacent angles, the 4 pairs will be angle A and angle B and angle C and angle D, angle D and angle A. These are the adjacent angles of the given quadrilateral ABCD. Children, now you have understood about quadrilateral. We can solve the exercise 4.5. Let us start with the first question of exercise 4.5. The first question reads, draw a rough sketch of a quadrilateral PQRS. Draw its diagonal, name them. Is the meeting point of the diagonals in the interior or the exterior of the quadrilateral? So the first part is you have to make the sketch of a quadrilateral PQRS. So this is a quadrilateral, that is a polygon having 4 sides. And this naming can be done in any way. Either you can start from this point or you can start from this point, but you have to go in order. If suppose I start from this point P, I will write here Q, R and S. So the first part is over. I have made the rough sketch of a quadrilateral PQRS. The second part is draw its diagonals. Now we learned the joint of non-adjacent vertices are called diagonals. So the non-adjacent vertices or the opposite vertices P and R and S and Q. If we join them, we get the diagonal of the quadrilateral. So I have made the diagonals of the quadrilateral PQRS. Name them. So which are the diagonals? The diagonals are PR, and because it's a line segment, this is the symbol, and SQ. PR and SQ are the diagonals of the quadrilateral PQRS. Is the meeting point of the diagonals in the interior or exterior of the quadrilateral? That is the last part of the question. You can see that the two diagonals meet at this point. If you want, you can name them. Name it as O. Okay. So where do you find this point O? Do you find it in the interior or exterior? We have learned that in a polygon you can define the three regions as interior, exterior or on. Okay, so here you find that the point O, it clearly lies in the interior of the quadrilateral. So where does the meeting of the quadrilateral lie? The second part of the answer is the meeting point of the diagonal or the intersecting point of diagonals PR and SQ lies in the interior of the quadrilateral. And the name of the quadrilateral is PQRS. Clear with the first question? Question number 2. Draw a rough sketch of a quadrilateral KLMN and state. And 4 questions have been given. You have to answer them based on the quadrilateral. First part of the question is draw a rough sketch of the quadrilateral KLMN. So this is a quadrilateral I have made. I will name the corners as KLMN. So this is the quadrilateral. Let us start with part A. 2 pairs of opposite sides. First you have to write 2 pairs of opposite sides. So if you take side KL, the pair opposite to it, the side which is opposite to it is NM. So the first pair will be KL and NM. And line segment, so you will use the symbol. And another pair will be, if you take the side KN, the side which is opposite to it is LN. So we have written 2 pairs of opposite side. Part B is 2 pairs of opposite angles. If you take this angle K and angle N are opposite to each other. And another pair will be angle L and angle N. Angle L and angle N. These are opposite angles. 2 pairs of adjacent side. So if you take the side NK, the side which is adjacent to it, KL, so you can write one pair as NK and KL, and if you take the side LM, either you can write it with KL or LM is also adjacent to MN. 2 pairs of adjacent angles. So if you take the angle K and angle N are adjacent, one pair of adjacent angles. And if you take, if you again want to take K, another pair you can write as K and L or L and M, angle L and angle M. So we have finished with exercise, the 2 questions of the exercise. Hope you have understood, children. Children, today we are also going to learn about a new concept, that is circle. Circle is an example of a simple closed curve. Here you can see a circle being made. It is a simple curve. Why is it a simple curve? Because it does not crosses itself. It is a closed curve. It is a closed curve because it does not have any specific endpoints. So it is a simple closed curve. But it is not a polygon. Why is it not a polygon? It is not a polygon because it is not made of line segments. So how do we define a circle? We define circle as a simple closed curve and it is not a polygon. So circle is defined as a simple closed curve which is not a polygon. So now we are going to learn about the different parts of a circle. Children, now we learn about the different parts of a circle, starting with center. Center is said to be the fixed point in the interior of the circle. Fixed point in the interior of the circle from where the circle is constructed. In this figure you can see this is a point from where we place our compass and make the circle. So this is the center of the circle, and because it is the point we use a capital letter, any capital letter to denote the center. So here the center of the circle is O. And remember, center lies in the interior of the circle. Now the next term you have to understand about the circle is circumference. What do you mean by circumference of the circle? The length of the boundary of the circle is called its circumference. That is, this boundary which forms the circle is called the circumference of the given circle. So this is the circumference of the circle. Or in other words you can say it is the perimeter of the given circle. Now the next term you have to understand about circle is radius. What do you mean by radius? The line segment joining the center to any point on the circle is called the radius of the given circle. That is, the line segment joining the center to any point. You can take any point on the circle and name it as A, and if you join this line segment, what do you get? You get the radius of the given circle. Similar way, if you take another point here, B, and join, you get another radius of the circle. So these two are nothing but the radii of the given circle. And because they are line segment, if you want to name any of the radii, you will name it as either it is OA or another radius which I have drawn here is OB. And you will find that these two radii are equal. Not only these two, you can draw a number of radius in the circle, number of radii in the given circle, and all the radii will be of equal length. Okay? Now, the next term you have to understand is the diameter of the circle. The line segment with its end point on the given circle, and it should pass through the center of the given circle. The line segment with its end point on the circle and passing through the center is called the diameter of the circle. For example, if I take another point here, C, and join this line segment CA is called the diameter of the given circle. Why? Because this line segment has the endpoints on the circle. It passes through the center O. So it is called the diameter of the circle. If you want to name, you can write the diameter as CA. CA is the diameter of the given circle. Another thing you have to understand here is this diameter is made of two radii, and these two radii are equal. You can say that the diameter is equal to 2 times the radius of the given circle. Okay? Or this length CA, suppose if it is 10 centimeter, here this part will be 5 centimeter and this is 5 centimeter. That is 2 times the radii of the given circle will give you the diameter of the circle. Now the next term which you are going to understand is the chord of the given circle. Now what do you mean by the chord of a circle? The line segment joining any 2 points on the circle. If you take any 2 points on the circle, if this name is A and this is B, and if you join these 2 points, what is it called? It is called the chord. It is called the chord, the line segment joining any 2 points on the circle. You can take any point anywhere and join them. You will get another chord. And if this point is C, and D. So here I have made two chords AB and CD, and these are line segments. Clear about a chord? Now the next term you must understand is arc of the given circle. Arc refers to any portion of a circle. If you take any point on the circle, if I take a point here X and another point here Y, so this part, that is XY, is one arc of the circle, or if you take this point CX, this is another arc of the circle, or Y and B, this is another part of the circle which is called the arc of the circle. So either you can write it as CX and denote by this symbol as arc, or XY, this is the arc of the given circle. Now the next term you will understand is the sector of a circle. A region in the interior of the circle which is enclosed by an arc on one side and two radius or radii on the other two sides. That is a region which is enclosed by the arc on one side and radii on the other two sides is called the sector of the given circle. For example, this region, that is AOB, is a sector of the given circle. Now another term is segment. Segment is also a region in the interior of the circle which is enclosed by an arc on one side and a chord on the other side. Arc on one side and the chord on the other side. So here the segment is segment. You can name it as LN. So clear with the term sector and segment of a circle. I will show you a picture on the screen which will make it more clear the different parts that you have just learned. That is the arc, sector and segment of a circle. On the screen you can see a circle and you can see the part which is shown in green, that is the region between the arc and radii of the circle is called the sector of the circle. The part which is shown in blue, that is the region between the arc and chord of a circle, is called the segment of the circle, and any part of the circle, that is called the arc of the circle. Another term which you have to understand when you study about circle is semicircle. What did we learn about diameter of a circle? Diameter is a line segment which has its two endpoints on the circle and it passes through the center. So if I consider the diameter AB, so you will find that the diameter divides the circle into two equal parts. These two equal parts are nothing but they are called the semicircle. They are called the semicircle. That is, a diameter divides a circle into two regions which are equal in area, which is called the semicircle. So what is a semicircle? The endpoints of a diameter of a circle divides the circle into two parts. Each part is called the semicircular region. Children, now you have understood about the different terms related with the circle. We can start solving with exercise 4.6. First question of exercise 4.6, from the figure identify. You have been given some terms to be identified from the given figure. So let us start one by one. First you have to write the center of the circle. So you can identify the fixed point from where the circle is made. So here the center of the circle is named as O. 3 radii. Radii is nothing but a line segment starting from the center and it's another endpoint on the circle. So many radii are there. Any three can be. It can be OC, can be OA and OB. These are all the radii of the given circle. Diameter is a line segment which passes through the center and endpoints on the circle. So here the diameter is AC. You have to identify a chord from the circle. What did we learn about the chord? It is a line segment which has its endpoint on the circle. So even the diameter is also a chord of the circle. Okay, diameter is also the chord of the circle. You can write diameter AC as a chord or ED is also a chord. Two points in the interior of the circle. You have to name any 2 points which lie in this region, that is within the circle. So the 2 points, they are the center O and this point P. So 2 points in the interior of the circle are O and P. A point in the exterior of the circle. A point which is neither in the interior or on the circle, but it should be outside, in the region outside the circle. So that is called the exterior point. That is, here the point is Q. You have to name a sector from this figure. Remember what is a sector? It is the area which is enclosed between an arc and 2 radii. So here this shaded part is the sector, that is the sector AOB. Between the arc AB and radii OA and OB. And the last part, the segment of the given circle. So segment is the region between the chord and the arc of a circle. So here the shaded part ED refers to the segment of the given circle. Now question number 2 has 2 parts, A and B. The first part is every diameter of a circle also a chord? So you have to clarify whether this statement is true or false. Is every diameter of a circle also a chord? So here I have made 2 diameters, and you know what are diameters? Diameter is a line segment which has its 2 endpoints on the circle and it has to pass through the center. So it is the 2 diameters are AB and here CD. So question is every diameter of a circle also chord? Now think these diameter as chord. Now what do you understand by chord? Chord is a line segment which has its 2 endpoints on the circle. So C and D are the 2 endpoints on the circle. So you can clearly say that every diameter is also a chord. So is every diameter of a circle also a chord? This answer will be yes. The B part is every chord of a circle also a diameter? Here you can see that I have made the chords. What are chords? They are the line segments which have its endpoint on the circle. So this is one of the chord PQ, another chord AB and XY. But here you will find that all the chords are not passing through the center. Only one of the chord which passes through the center, that is the diameter. So is every chord of a circle also a diameter? No, the answer will be no. It will be only a diameter if it passes through the center of the given circle. Question number 3 is draw any circle and mark. You have been asked to mark all these on the given circle. So I have made a circle. First you have to mark the center. You know that center is in the interior from where we construct the circle. So I name the center as O. So here the center is O. Next is a radius. For radius we have to take any point on the circle, that is on the circumference of the circle, and join it to the center. So if I name this point A, so one of the radius is OA. It's a line segment. Diameter is when you take any 2 points on the circle and it has to pass through the center. So here the line segment CD passes through the center of the circle with its endpoints on the circle. So CD is the diameter of the given circle. Sector is a region between an arc and 2 radii. So this can be one of the sector because this is also a radii and this is also a radii. So this will represent the sector. So you can write the sector as sector OAD. Segment, what did we learn about segment? Segment is a region between the chord and an arc of the circle. So if you take any 2 points and join it, so this region will be one of the segment of the circle. So here the segment is the shaded part, XY is the segment of the given circle. A point in its interior. So here you have the point O which lies in the interior, or you can take any other point and name it and say that this point L lies in the interior of the circle. A point in the exterior, you have to take a point outside the circle and you have to give it a name. So this is the point which lies in the exterior of the circle, that is point Z. an arc. What is an arc? Arc refers to a portion of the circle. So here you can name any arc. One of the arc can be XY. So this is one of the portion of the circle, and which is referred to as the arc of the given circle. So in the given circle, we have named the different terms that have been asked. Question number 4. You have to say true or false to the given true statement. The first statement is two diameters of a circle will necessarily intersect. So here you can see the two diameters AB and CD, and you can see they are intersecting at the point O. So whenever you make the diameters of the circle, you will find that they will intersect, and they will intersect at the center of the circle. So this statement is true. Second part is the center of a circle is always in its interior. What did we learn about the center of the circle? It is a fixed point from where we construct the circle. So it will always lie in the interior of the circle. So this statement is also true. So children, with this we have completed the lesson Basic Geometrical Ideas. Hope you have understood the different terms that we have learnt in this lesson and how to represent them using symbols. Hope you enjoyed this lesson, and I hope you will keep practicing and keep learning. Till we meet again, goodbye.